Let's look at the homework 11.4, problem number 7. All right. So we have actually a solution given in a kind of implicit form, and we have a couple of initial conditions. Then we want to find the y value when t equals 6. All right. So let's just do this problem. All right. So here at the start of the study, 40% of SNIA have the characteristic B. So we know that, let's see, f of 0 is going to be 0.4, right? So let's plug it in. So you have a 0.4 times 2 minus 0.4, so it's a 1.6 over 1 minus 0.4, so it's going to be 0.6 squared, right? So this is equal to c e to the 0, so it's going to be just c, right? So this is going to be, let's see, I'm going to just multiply top and bottom by 100 so that I don't have to look at the decimal point. So it's a 4 times 16, and that's 6 times 6, so 6 times 6, right? So we can cancel 4 here, so that's 2, and that's 3, and that's 3, and that's 1, right? So that comes out to be, so C is 16 over 9, right? And the second piece of information is when t equals 5, y is 0.8. So y of 5 is equal to 0.8. So this means that, let's see, so 0.8. 0.8 times 2 minus 0.8 is 1.2 over 0.8, so 0.2 squared. So 0.2 squared. That's equal to, C is already know 16 over 9. And then t is 5. So you have e to the 2k times 5. So it's a 10k. Right? So we got that. All right, then let's see. So I guess we need to do a similar calculation. All right, so I'm going to multiply top and bottom by 100. So you're going to have 8 times 12. And then you have 2 times 2. All right. So in this case, so we can just cancel. So there's 2 and 2 canceled. And it's 4, so it's going to be 2. So it's going to be 24. So this is equal to 24. All right, and so let's see. I'm going to solve for. All right, I'm going to multiply top and bottom by 9 over 16, so that we have e to the 10k, so is equal to. All right, so it's going to be a 24 times 9 over 16, right? So we can cancel, let's see, so this is a multiple 4, right? So 6 times 4 is 24, and that'll be 4. Actually, I can divide by, let's see, so that was 8, so divide by 8, so it's a 3, and that's 2, right? So that's probably the value. So it's a 27 over 2, right? And what we're looking for is we have to be a little bit careful. So we're looking for when t equals 6. So this is the equation we need to solve. So you have a y and 2 minus y over, right, 1 minus y squared is equal to, right, c is 16 over 9. We already have that. And then we plug in t equals 6. So you have e to the, let's see, 2k. So it's going to be a 12k, right? So so this is the value we're looking for, right? So we need to find the e to the 12k. So I actually have e to the 10k. So what I'm going to do is I'm going to raise it to at 12 over 10 power. That way you have e to the 12k. Right, so this is equal to 27 over 2. Raise it to the it's a 1. Can I write 1.2 power? So 1.2 power. All right. So this is going to be 16 over 9 times 27 over 2 to the 1.2 power. All right, so let's. I'm going to use actually cheater a little bit using GeoGebra to find y here. All right, so I'm going to open up GeoGebra. All right, so I'm going to put the right-hand side as the y value, so it's a little bit confusing. So instead of y, I'm going to use x. So here, so y value, I'm going to say 16 over 9. And then you have 27 over 2, raise it to the 1.2 power, right? So this will give us the straight, let's see, horizontal line. So I'm going to actually shrink a little bit so that we can see the, all right? So that's where it is, right? Then I'm going to sketch the left-hand side, but instead I have to use x instead of y. So it's going to be x times 2 minus x divided by 1 minus x squared, right? All right, so then we are looking for the intersection. So we are looking for that intersection point. So we can just say, I'm going to intersect this straight line and this curve right there. All right, we found one. All right, so you can see that at the intersection has x coordinate 0.84, which corresponds to the y value here because we're using x instead of y. All right, so let's go back and type it in. So it's going to be 84%. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.